Alright guys, today we're going to look at factoring polynomials. So go ahead and have your notes ready for this concept of a review. And let's take a look at our first example. When you're asked to factor, you're really just doing the division property. You're dividing out. The thing is what they have in common. So it's, distributive property is multiplying in. Factoring is dividing out. So you want to see what I can divide out of both of these terms, 4a squared and 8a, and they both have a 2 in common and an a. So 2a is what they have in common, but you always want to look for the greatest common factor. So the biggest number that goes into both of these are 4 and then the a. So if you remove a 4a from both terms, as you see in that first equals, what's left behind is an a and the 2 when you divide it out. So that a and the 2 remain back in the parentheses, and that is factored form. Factored form always, you should visually see a parentheses or 2. With our next example, and of course if it goes too fast, just pause, rewind. Our next example is factoring using the x factor, and this is what I do with all that are not GCFable or GCFable and then still quadratic. So this is a quadratic trinomial because there's 3 of them. In this particular case, I go ahead and set up the what is considered the A, B, and C. So the A term is a 1, the B term is -8, and the C term is 12. And then what I do is I multiply, or I see what number, set of numbers, multiplies to A and C, which is 12x squared, and adds to -8x. And the reason I call it the x factor is, as you can see, there is an x that I draw to kind of help me organize my brain process, my thought process. So I look at numbers, okay, well, what multiplies to 12? So I would say 3 and 4, but that doesn't add up to -8 in any way. So then I find another set. Well, 6 and 2 works. If I add them, it gives me 8, but I don't want just 8. I want -8. So then I need to once again see what multiplies and adds correctly to the top and the bottom. So I have -6x and -2x. They multiply to give me the 12x squared, and they add to give me -8x. All right, cool. That's the hardest part, is finding the two numbers. So the next thing I do is I go ahead and rewrite the problem from the top. The x squared and the 12 come out. I should say come down. And then, of course, the -8x, I rewrite it as the two terms, -6 and -2. Then within each side of the x factor, I go ahead and it's called factor by grouping because there's a partnership in each side. I find what they have in common separately, just like the previous example. Well, on the left side, I have the x squared minus 6x. They both have an x in common, so I divide out an x, and I'm left with x minus 6. On the right side, they both have a -2 in common, and the reason it's negative is because the leading coefficient, which in this case is -2x, is negative. So you always take a negative out. And then what remains is x minus 6. Now what's unique about this factor by grouping is that x minus 6's, or in that whatever's left in the parentheses, will always match if you're doing it correctly. So then the x minus 6 is my new common term for each side. So I take that out, or I write it down, and then what's left is the x and the -2, so I write that in its own parentheses. Notice I see parentheses, those are factors. I am done with that. I can always check it by multiplying that those binomials out, and I should end up with the original problem. So x minus 6 and times x minus 2 would be the answer for example 2. Let's take a look at example 3. In example 3, we have 6x squared and 7x minus 3. It's a quadratic. It's a trinomial. There's nothing in all 3 that they have in common, so I'm going to go ahead and do the x factor. I find out what multiplies to -18 and adds up to 7x. Well, the only numbers I can think of that work is a positive 9x and a -2x, which is what's, my thought process is there on the left side underneath the 7x, and they add up to 7, or 7x. So then I go ahead and bring the first term, 6x squared and the negative 3 down. Instead of 7x, I write the two numbers I found, the negative 2x and the 9x. Factor by grouping, so the first parentheses, I see what they have in common, the greatest common factor. 2x, and the second parentheses, the 3. Notice the 3x minus 1 they have in common, so I write it. And then what's left behind is the 2x and the 3, so I rewrite that in its own parentheses, and that is itself. Those two are my factors. Special products is something you can utilize. Instead of doing the x factor, these are some special cases that will help you. The first one is a perfect square trinomial, and the second one is a difference of squares. I color-coded them to show you the difference. For the perfect square trinomial, first of all, a trinomial, there's 3 terms is what you're going to end up with. Initially, you're going to have the perfect squares in the left and the right. I'm sorry, in the left, the left. The first term and the third term are both going to be perfect squares. And then you just square root them to get what it's inside the parentheses. So the square root of a squared is a. The square root of b squared is b. And then the signage is in the middle is determined by the original problem, the original trinomial. If the original trinomial had a plus, then you put a plus. If it had a minus, like in the second part of your slide, it has a minus, a squared minus 2ab, then you put a minus. The reason it's a trinomial is because the a plus b squared, if you were to write it 2 times, and FOIL it out or multiply it out, you end up with a trinomial. So remember, it goes back and forth. Factoring is dividing, multiplying, they undo each other. So you can quickly check your answers. The difference of squares, you end up with, in the original problem, 2 terms with a minus in the middle. That's the only time it'll work, is the difference of squares. I call it dots, difference of 2 squares. So the first term and the last term would be perfect squares. So you square root them like in the previous perfect square trinomial. But this one, it's not a trinomial. There's squares. There's 2 squares. So you have to think, okay, I cannot have that middle term. So if the signage is, and the opposites, one's plus, one's minus, and it doesn't matter the order, then that would cancel out that middle term. So difference of 2 squares. Let's take a look at the first. The first special product is the perfect square trinomial, PST. If you notice, the first and last term, well, nothing is in common in all of them. You should always check for GCF. After that, it's still a quadratic, so you can do the x factor, but once again, the shortcut is that the first and the last are perfect squares. So the square root of those is a 2x and a 5. The signage, positive. And then just square it because it's perfect squares. And now once again, to check it, you just look at the box there that I provided you. It says the middle term is equal to 2x times 5. Well, 2x times 5 of my parentheses is 10x. And if I double it, because you'll have 2 of them, since there's 2 parentheses, and even though you don't see 2 parentheses, but that exponent tells you there's 2 parentheses. When you multiply it by 2, because there's going to be doubles, you get that 20x. So voila, 2x plus 5 quantity squared is your answer for that trinomial. Dots, difference of 2 squares. Difference means minus, I see that. There's 2 squares in the first and the last term, so you just square root both of them. And then think to yourself, I don't want a middle term. It has to cancel out, so pos neg. Okay, hopefully that helps. Rewind, ask questions the next day.